Up until this moment, we'd only seen dynamic content creation at the start of the application, when the article elements were added to the page based on data contained in the JavaScript array of objects representing those articles. Now we move to the next app, which shows how to create, modify and delete content at any time during the application runtime. First, we'll make a step back and use Handlebars again to be able to compare it with a React version that will come next. A to-do list app may be a good example, as there is plenty of interactions with the user that trigger various changes in the way the app is presented to us on the screen. First, the app loads initial hard-coded data, much like all the previous examples. Then things get more interesting than before, as you can modify the data by creating a new task, marking a task done or undone, updating task name, and deleting a task. You can also filter the tasks list by status and name, which doesn't modify the underlying data, but temporarily hides or shows tasks, depending on the filtering conditions. By default, you see all the tasks as no filters are applied. Also notice when you create or delete a task or filter the list, the tasks counter updates with the current number of filtered and existing tasks. After clicking on the task name, a text field appears with two buttons. The first one to save the updated name, another one to cancel the editing. There are also some less visible examples of interactivity. You cannot create a task with no name or rename a task to an empty name, as the submit buttons get disabled. Finally, when you delete all the tasks, the text changes until you create a new task. So there is plenty of interactivity in this example. As you may predict, much more code will be necessary to handle all that functionality than in the case of the articles list project, and much more effort will be required to preserve the codebase maintainable. In the Handlebars app, we split the code into components containing JavaScript and CSS files. In the index.html file, we import all the CSS files and the main JavaScript file as a module. There are two handlebars templates for the task element and the task name editing element. We start with the main script that populates tasks list with the hard-coded data right after the uploads in the browser. This is basically what we've described already in the previous projects. The rest of the scripting concerns data modification like adding, deleting, editing tasks, and data browsing like filtering tasks. In this app, some elements like the new task form or the filters panel are already there at the start, where other elements like the task block or task name form are meant to be created dynamically. In the first case, we can simply find those elements and listen to the UI events, like pressing the submit button to create a new task. But in the second case, we need to attach the listeners dynamically every time the element is created, like pressing a button to delete a particular task. The Handlebars app presents an imperative approach to UI building. To achieve all the functionality, we explicitly manipulate elements and we derive the application state at a given moment from the hierarchy of elements. We update the total tasks number text by counting all the list item elements inside the tasks list. We filter tasks by switching them on and off using the display none CSS rule, and we update the filtered tasks number text by counting those list item elements that do not have this property set. We add a new task by directly appending to the tasks list a new list item element with the HTML of that task. We remove a task by directly removing its list item element from the list. We update a task name by directly replacing the text inside the HTML element with the value of the corresponding form input, and so on. So it turns out that in a more dynamic app like that, organizing the templates, updating the HTML content, and managing the state is quite challenging. If we take into account future maintainability of our code and performance of our app with all the possible edge cases that may eventually pop out, we're suddenly left with much fewer options for a reliable UI building solution than in the case of a simple app without much state management like the articles list project before. And that is why we'll now move to the React example. The articles list React app didn't contain state management. We were just passing props down the order. There was no interaction between the user, but this time it's different. The to-do list app shows why React wins over Handlebars-like tools when it comes to content modification and state management. In the React app, the code is once again split into components. We start with the web app script where we render main view component with an instance of a data store implemented with MobX. The main data store file contains an array of tasks and a task filter instance. You can see the observable, action, and computed decorators inside the data store classes, and the observer decorator above all of the React component classes. When any observable variable or any computed result handled by MobX updates its value, any component that subscribes to those changes re-renders thanks to the MobX magic. In the Handlebars app, the code was mixed in domain logic with logic related to manipulating elements and managing state. In the React app, the declarative approach to UI building, combined with state management provided by the MobX library, makes it possible to focus solely on the domain logic. State changes trigger content updates in such a way that we don't need to think about creating, updating, deleting elements and manually handling lifetime of event listeners. When the observable data handled by MobX changes, the app responds by re-rendering its relevant fragments. How the app is displayed at a given moment is a reflection of the underlying data. Selecting a state management solution for React apps is a topic on itself, but for me personally, React and MobX is a standard combination that provides superior developer experience to other state management approaches like Redux or recently introduced hooks. Now we move to the last example, which is an evolution of the previous one. First, we convert JavaScript to TypeScript. We need to replace JS and JSX file extensions with TS and TSX respectively, add tsconfig.json file, and configure Webpack to use TS Loader to compile our files to JavaScript. Inside the code, most of the work is based on adding types to function arguments and class fields. To do that, we often need to declare interfaces. We also need to add a global declaration of the hard-coded tasks data we get from the separate script. Now if we try to assign a numeric value in place of a string value, or pass to the function an object with a wrong key or make any small mistake one way or another, we get a compiler error. That kind of mistakes happen every day, but without TypeScript, we end up with a runtime error in a browser that could break the application, or what may be even worse, with an app that functions differently from what we expect, producing hard-to-replicate results. In my opinion, TypeScript is the most important technology featured in this video, even if the main topic revolves around templates and state management. I've already mentioned that I prefer React with MobX over any other solution when working on front-end apps, but my TypeScript preference is even greater. I'd rather use Redux instead of MobX or Angular instead of React if it meant I could avoid untyped JavaScript codes. For me, TypeScript brings massive confidence in the codebase, which translates into improved productivity and more income from the projects. When we convert to TypeScript, we end up with a codebase that is resilient to the most common bugs of the JavaScript world, so we can focus on resolving real problems. Next, we convert Sass code to styled components. To do that, we use Emotion library, which translates styles written inside template literals to the fully fledged CSS applied to HTML elements. Those styles are assigned to React elements that we can use within our component instead of regular elements like div or span. So in the result, we get rid of the SCSS files and store our styling inside the JavaScript files, or the TypeScript files in this particular case. I prefer to keep my styles in the same file as the component they apply to, unless there's more of them, in which case I create a separate file from which I import the styled components into the script with the corresponding React components. The big advantage of CSS inside JavaScript approach is that we don't need to worry anymore about the naming conventions for our CSS classes, as the styles, after they get applied to the website, obtain unique class names, what avoids name conflicts. Moreover, you can nest CSS selectors. just like in the Sass files. You can use variables from the JavaScript side to store common values. And you can apply styles conditionally. So in summary, this combination of React and MobX with TypeScript and styled components is, at least in my experience, the best foundation to create a successful front-end app in a rapid prototyping style without sacrificing the long-term maintainability of the app. So I hope I improved your high-level overview of the front-end technologies featured in this video, and now you know better why front-end frameworks and libraries may be a good choice over vanilla scripting, especially in case of apps with bigger amount of interactivity that demand a sensible state management on the JavaScript side.